to be squared. That's what that is. Plus, it's going to be minus abx1 minus bc minus b squared y1 all over a squared plus b squared to be squared, and this needs to be squared, and finally it's the square root of all of that there. It's getting a bit crazy. What I'm suggesting is that there's a minus common here, we could take it out, okay? There's an a common, we could take it out, so we could take a minus a out, which then becomes squared, which is actually like taking out a positive a squared. So actually this becomes, when we do this here, I'm just going to write it down. So actually let me just take this here for a moment, this particular term here, just as an example. So I'm just going to take the minus ab y1 minus ac minus a squared x1 just to show you this and square that. So that becomes, it's minus a times by1 plus c plus ax1, okay, all squared, which is the same as minus a squared times by1 plus c minus ax1 all squared, which is the same as a squared times by1 plus c minus ax1 to be squared, okay? Which, let's just put this in the other form here. Let's see what we have here. Am I right in saying that? That's I took out an a. That's common here. An a out. An a out. An a goes, leaves us with an a there. Perfect. Okay. So now what we end up with is let's just show you this. Let me just fold this over. So, oops, nearly there. Okay, so taking this particular term here, okay, this particular term here, as I said, taking the minus out and the a outside, this becomes a squared times what's left behind here is a by1, and let's say that's an ax1, so plus an ax1, and it's a plus a c here, and that needs to be squared, okay, and that's all over a squared plus b squared, which needs to be squared, plus doing the same thing over here, we can take out minus 1, and we can also take out a b, okay, so what's left behind over here, okay, is if we were to do that particular thing here, in this case here, it's minus abx1 minus bc minus b squared y1 all to be squared. As I said, we take out a minus b this time, so that's a minus b times an ax1 plus a c plus a by1, okay, and that all needs to be squared, which gives us, once again, it's b squared times ax1 plus c plus by1 squared, which is what we had previously, but this time we took the b's out. So let's just actually put that in the form, okay? Actually see what's happening here. It's plus this, it's going to be plus b squared times, well, actually this is the same, okay? This is the same as what's inside the brackets here, okay? Actually, that should have been a plus here, down here, okay? So this is actually exactly the same as that's what's a b squared times a by1 plus an ax1 plus a c, all over an a squared plus a b squared to be squared. Okay, that's squared. And this is all raised to the power of a half. We're nearly there, okay? There's actually, we could add these two things together, okay? Yes, same fractional amounts, okay? So this becomes all over a squared plus b squared, okay, to be squared, okay? That goes into that once, which gives us a squared times by1 plus ax1 plus c to be squared, plus that goes into it once, so it's plus b squared times by1 plus ax1 plus c to be squared. It's the square root of that, okay, the square root of that, which is the same as, oh look, there's a common term here, it's by1 plus ax1 plus c, which is the same as, let's say, ax1 plus by1 plus c, okay, to be squared, which needs to be multiplied by a squared plus b squared all over a squared plus b squared squared, and it's the square root of that, okay, so it's the half of that. Okay, and you can probably see what's happening here is that this cancels out with the square, which leaves us with ax1 plus by1 plus c squared over a squared plus b squared, and it's the square root of this. It's the square root of that thing here. Oh, the root of the root here of the square gives us ax1 plus by1 plus c. Actually, we're going to take the positive version of this, okay? So it's the absolute value of it all over the square root of a squared plus b squared. Okay, so guys, there you go. That's the distance formula. Okay, now this took a fair bit of time. It took 26 minutes, but I mean this would be one of the more complicated ones that you'd probably see if you were to be asked a proof to do maybe just before in fifth year or sixth year, or maybe on the higher level syllabus. Okay, guys, once again, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. There was a lot of work involved in this, but it was just algebra. Okay, it was just keep persevering, don't give up, take your time. And what we did was we've calculated a formula. Now we derived a formula that allows us to calculate the distance between a point and a line. More importantly, allows us to calculate the perpendicular distance between a point and a line, where you've been given the line and you've been given the point. So once again, guys, thanks for watching. I hope that this was intuitive, and more importantly, I hope that was helpful for you. And thank you. Bye bye.